Good evening and welcome, everybody. My name is Seth McGowan. I'm the Vice President of the Adirondack Sky Center and Observatory, and I will once again be your host for tonight's event. The Adirondack Sky Center and Observatory is proud to bring you the next presentation in the now famous Cygnus series. This is a series of live, virtual, and interactive educational presentations that take place each Friday night starting at 7 o'clock through Columbus Day weekend. And we've developed this series in order to continue our educational programming during the period of social distancing and limited gatherings. So as much as we hope to see you again in person soon, until then, register each week for a new and exciting program. In that same spirit, look for notifications about our now active live, virtual, and interactive stargazing events right from the roll-off roof observatory. These are not images, but this is a live feed from our Celestron 14-inch telescope right into our Zoom meeting. So you'll see the sky live as you would, as if you were here, of course, without the frigid air or sometimes bugs. For those of you who might be new to the Adirondack Sky Center and Observatory, you'll notice our location is great for astronomy, and that's why we are where we are, given our Class 4 Bortle skies. But don't stop there. Our Astro Science Center is under development and will become an important destination for all ages in the future. Numerous activities and interactive exhibits within the museum will educate and thrill visitors as we on Earth continue our exploration into space. In addition to the exhibit hall and continuing our hands-on approach to astronomy, our makerspace is completely interactive, where visitors will engage in virtual reality, telescope making, and much, much more. Our spacious lecture hall will be a great place for larger groups to hear about the wonders of space, and our premier state-of-the-art and digital planetarium will take you on trips beyond your imagination. We, of course, invite you to be part of this exciting future of the Adirondack Sky Center and Observatory by becoming a member, by visiting our website, adirondackskycenter.org, and clicking on the donate button. And you can consider giving a generous gift to help make our Sky Center a reality. And now on with tonight's show. Before we begin, you notice that your microphones are muted. This is to ensure the enjoyment for everyone who's there, who's with us tonight. Feel free to use the chat feature to ask questions during the lecture. We'll have some Q&A when we get done. And our presentation tonight, as well as all of our talks, are available on YouTube, on our YouTube channel. You'll be provided with the links to all of those things through the chat area during the course of tonight's presentation. And now it's my pleasure to welcome back to the Adirondack Sky Center and Observatory and newly appointed assistant professor in the physics department, physics and astronomy department of SUNY Oneonta is Dr. Valerie Rapson. Tonight's presentation, the Zooniverse. Take it away, Valerie.
Excellent. Well, thank you very much, Seth. It's great to be here. It's always wonderful to see everybody from the Adirondack Sky Center. So as Seth said, I'm Dr. Valerie Rapson. Many of you know me from my previous position at the Dudley Observatory, where I was outreach astronomer and the director for a little while. And now I moved on to teaching undergraduates at SUNY Oneonta. And I'll also, once COVID is over, be helping with their planetarium and their observatory. So I'm sure there's lots of great partnerships we can talk about moving forward. Today, I thought I would do a really fun and interactive presentation for everybody on this cool website called the Zooniverse. Some of you might be familiar with it, others maybe not, but that's okay. So what I'm going to do is share my screen here. I have a pretty short PowerPoint presentation, and then I'm going to bring you to the Zooniverse website, and you guys are going to help me do some real science. By the end of the evening, you are all going to actively contribute to real astronomy and scientific research. And then after the lesson, hopefully you'll be inspired to stay at home and do some more of this really fun classifying of galaxies, searching for supernova, looking for exoplanets, all sorts of fun things you can do on this website. Let me switch over here to my screen. There we go. All right, so I've titled this a tour of the Zooniverse, kind of a play off of the word universe, but the website is called zooniverse.org. And before I explain to you a little bit more about this website and how it works, we're going to practice using some of the annotation tools in Zoom, because I'm going to have you help me draw and annotate on the screen later. So I'd like to know if any of you have heard of the website Zooniverse before, or any of the projects. So if you have, I want you to use the annotate tool in Zoom to put a check marks in the appropriate boxes here. If you need to know where the tool is, it's either in the top bar of your screen or maybe it's on the bottom bar. If you have the Zoom program downloaded, you just look for the annotate tool in the bar, and then you can put a stamp or you can draw. If you're on the web version, you may or may not have access to the annotate tool. I'm not sure what the latest update has, but it looks like some people have found it. So I'll give you a second to find the annotate tool if you can. And you can put a little mark on the screen. And the best one to use is the stamp tool if you're able to, because that will stay there on the screen. So you can put some little hearts on the screen, you can put stars on the screen, whatever you'd like. And I'm going to trust that you're only going to doodle on the screen when I tell you to today. You know, when I teach middle schoolers, it's a whole other story, but I think I can trust the adults here today. Excellent. Yeah, it sounds like many of you have found the tool. That's perfect. Excellent. So it looks like here we have a bunch of people that have said no, they haven't heard of Zooniverse, which is great. This will be brand new to you. Hopefully you'll find it a lot of fun. A couple others have heard of it, and even some have participated in projects, which is wonderful. So what I'm going to do now is I'm going to, excuse me, clear all the annotations. So I'm going to ask you to stop doodling on the screen for a few minutes. And then once we get to the Zooniverse website, we're going to do some more drawing on the screen here. So let me clear all the drawings. Perfect. So let me share a bit about what the Zooniverse project is, especially for those who haven't heard about it before. So Zooniverse is a collection of citizen science projects where the general public gets to help scientists analyze real scientific data. I am not specifically involved in the Zooniverse. I don't have any research that's tied to this, but I do know a couple of professors, some of which are in New York State, that have participated in or helped provide some data to some of the Zooniverse projects. The projects are not just astronomy based. We're going to focus on astronomy ones today, but if astronomy is not your top interest, there's projects in a whole variety of different areas, from earth science to psychology to history to literature. It's really, really fun, and it's one of those things where you get on the website and all of a sudden 3 hours go by and you're just like, a blink of an eye. I can't believe I spent 3 hours on this website. It's so much fun. So why citizen science? Why did this Zooniverse website come about? What's the point of getting the public involved in all of these projects? Well, citizen science in general really enables research to be done that's not possible with other resources. So maybe there's not enough funding to get all of the data analyzed, or maybe there's just human constraints, not enough people, not enough graduate students to help out. So often we see things like, you know, we have projects where there's a ton of data. For example, at the bottom of the screen here, you can see this is actually some data taken of a star that has a planet orbiting around it. And what you're looking at here is brightness of the star on the y-axis of the graph and time on the x-axis. And the star is this level of brightness most of the time. And every once in a while, these data points down. That's when a star crosses in front, or excuse me, a planet crosses in front of the star and blocks out the star's light. There's tons and tons of these light curves in big databases. And to give you a sense of scale, TESS, the current exoplanet mission, measures the brightness of tens of thousands of stars every 2 minutes. So literally for tens of thousands of stars, there's many of these graphs, and there's just not enough time for everybody to look at them. Some things require a human eye, as you'll see with one of the projects we're going to demo later. A computer can do some analysis, but we're really relying on the human eye to pick out errors or to pick out things that a computer would classify as a supernova explosion, but when a human sees it, they know it's actually a glitch in the system. And finally, it's fun to get the public involved. right? We want the general public to be able to help and contribute with science, and hopefully it'll get you excited to follow these projects a little bit more in depth. So just briefly, I wanted to tell you about the history. Where did this all begin? Well, it started with a single project called Galaxy Zoo back in July of 2007. And what astronomers did is they took 900,000 images from the Sloan Digital Sky Survey, this collection of pictures of galaxies, and they put them up on a website, and they asked the public to classify the galaxies based on their apparent shape. So here's a screenshot of the old system back in the early 2000s. They basically showed you this picture and said, here's a fuzzy blob, it's a galaxy. What does it look like? You know, does it look like it's got clockwise or counterclockwise arms? Is it a fuzzy blob? Is it a bright star? And literally you just go through and do some picture matching. And we're going to practice this a little bit later. But it's very simple, and ultimately it helps the astronomers classify galaxies. And the astronomers that originally did this thought it would take years for them to analyze all of the data. They didn't think it would be that popular, but they were very, very wrong. 150,000 people made 50 million classifications just in the very first year of the project. So after that, they knew they had something, and they started to expand this project out to a whole variety of different areas of science. Now, when they were looking at pictures of galaxies, what they were actually doing is having people help classify galaxies based on what's called the Hubble classification scheme. Some of you might be familiar with the Hubble tuning fork. That's what you're seeing here. We've got different types of galaxies: elliptical galaxies on the left, the ones that look like yellow fuzzballs, and our classic spiral galaxies on the right, broken into two categories: ones that have bars across the center, those kind of stars collected in a straight line, others that don't. And there's all sorts of details if you really get into it. You know, how bright is the center? How tightly wound are the spiral arms? What's the shape of the elliptical galaxy? There's all this deep science involved. But the best part about Zooniverse and these citizen science projects is you don't need to know any of that. You don't even need to know that you were basically doing a Hubble classification of galaxies. All you have to do is follow a few simple steps to do some picture matching and ultimately help the scientists figure out what the galaxy classification is. But all of these projects are designed such that you don't have to know any science, so you can jump into any area that you're interested in without any prior knowledge. And every project has a little, literally 2-minute tutorial that teaches you how to do it. And in 2 minutes, you can become an expert in classifying galaxies, and you can help the scientists go through the process and have some fun looking at pictures of galaxies. So right now, what projects are available? There's over 100 projects available. Everything from looking at pictures of raccoons and watching them open puzzle boxes. This is legitimately a real project. It's lots of fun. If you're not into raccoon watching, you could also do some more historical stuff. There's been uploaded some Australian prison records, and they want people to transcribe them. And I know the picture is really small here, but basically what this is the name of the prisoner and some of the things that they did wrong or that they were fined for. So you can read all these silly things like, you know, got caught with a whistle in prison or something silly like that, and how much money they were docked or how much time was added to their sentence. And these are all historical records, so nothing current, but neat kind of history things. And then something we're going to do later on, if you're really into astronomy, you can, you know, hunt for supernova. And I'll show you how to do that. How do we find supernova explosions in distant galaxies? So moral of the story, there's a whole lot of different fun things that you can do on this website. So let's finish up here so we can actually get to playing around. How does Zooniverse work? Well, I mentioned that all of the projects have a few-minute tutorial. I'll walk you through how to do the different projects. The data is analyzed by multiple people. So when you classify a galaxy or when you look for an exoplanet, it's not just you and only you. It's you and 1,000 other people looking at the same picture. And the scientists rely on collective knowledge for accuracy. So you don't have to stress about whether you're right or wrong. You take your best guess. And the idea is that most people will kind of, you know, go in the right direction and hopefully classify the galaxy properly. And it's okay if you make a mistake or if you're not sure. It's not gonna, destroy the research. There's also a discussion forum. I won't show you that today, but if you're really into it, you can chat about things there. And that's often where some of the big discoveries are made. People see weird things in the images or ask a good question, and the researchers actually get on there and look into things in more detail. And then finally, the researchers, once they're done with the project, they gather up all the data, they do some further analysis, and they publish the results. And if you actually create a login, which you don't have to on the website, but if you create an account, it's totally free. And if you discover something cool under your username, you will get credit for it in the research paper. So that's just a little incentive to actually work on this afterwards. So that's kind of your quick intro of what Zooniverse is. And now I'm going to switch over to the website and we're going to take a look at the newest version of Galaxy Zoo. So we'll classify a couple galaxies. And then we'll also take a look at Supernova Hunters, and depending on what time it is then, we can take a look at some other things as well. Any questions at the moment? While I switch over to the website, feel free to take a moment and ask a question or put it in the chat box if you'd like to. No questions? All right. So here I'm just sharing my Chrome page, and this is the Zooniverse website, zooniverse.org. And when you get onto the website, all you got to do in the upper left, you can click projects, or it's actually right here in the middle to see all projects. Once you get here, every day they highlight some different projects. So today they're highlighting Disk Detective, which is looking for disks around young stars. Snapshot Hogue, this one's cool. This one you must be looking at pictures of animals, probably helping classify what animals there are. All sorts of fun stuff, but we're gonna keep focused. We're gonna go looking at the astronomy one. So we're gonna scroll all the way to the right because they have it labeled as space instead of astronomy. So it's the last one here. We click on space, we can see all the projects. So there's all sorts of neat things. If you're into the history of astronomy, you can look at some of the old logbooks from the female computers. You can look at terrain on Mars and help train the Mars rovers. It's just amazing how much fun stuff you can do. But we're gonna focus on some of the basics since I don't have hours to spend with you today. We're gonna go to Galaxy Zoo. So this is the newer version of the original Galaxy Zoo. Click on this. And I'm going to click here to the classic version. You guys can read a little bit more about it if you want. You can always learn more. That gives you a little bit more of the science background if you're interested, but we're just going to jump right to the project today. So here what we're going to look at is pictures from the Blanco 4-meter telescope of galaxies. And we're going to learn how to do picture matching to classify galaxies. If you were by yourself, you could literally go through this, 2-minute tutorial reading through how to do it, but you're with a real astronomer here. So we're going to close that and I'm just going to tell you how to do it because this one is like the easiest of all the projects. So what we're going to do is take a look at the picture on the left. All of these pictures have theoretically been centered on what the computer believes is a galaxy. And what we're going to do is click the buttons on the right to decide what we're seeing. So in the first question here, you look at the picture and it's asking, does it look smooth? Does it appear to have features? Or do you think it's a star or an artifact and not actually a galaxy? And depending on what you select, it's going to bring up some new questions for us to answer. So again, we don't have to know any science. We don't have to know what that Hubble classification scheme is. We're just going to answer the simple questions. So you guys are going to do this, not me. I want you to go back to that Annotate tool, and I want you to answer the question. So use the Annotate tool and just draw somewhere on the boxes what you think the answer is. So what would you classify this as? Smooth? Do you think you see features? Or do you think this is a star or an artifact? Go ahead and do that. What do you think? Yeah, excellent. And remember, don't stress about being right or wrong. There really is no right or wrong. And Zooniverse is not going to tell you whether you're right or wrong because it doesn't know, right? You are literally helping out with the science. All right, so it looks like we have some general consensus for features or disks. So I'm just going to clear these as we go, and I will click what you guys tell me to click. So I don't annotate. I want to click. So you click features or disks, and then we click next, and it's going to ask us new questions. All right, so keep going. Could this be a disk viewed edge on? Does it look kind of, sideways and skinny? Or do we, actually see some features? Do we see spiral arms? What do you think? Doodle on the screen here. Ooh, we got a good mixture here. This one's going to be hard for me to pick. I think we've got general consensus for the bottom, but quite a few of you were clicking the top one. So we'll go with the bottom one here, just whatever I think is the most. Click next. Give me a second to clear the annotations here. There we go. All right, what's next? Do you see a bar? Do you think you see a straight line kind of across the center of the galaxy? And if so, how strong is it? And just look at the pictures, match up the pictures. What do you think? No bar, weak bar, strong bar? Sometimes it's not easy to tell. Sometimes it's really obvious. So you always just want to take your best guess.
Hello, can I ask a question?
Yes, you may, Bridget, go ahead.
I don't think I'm able to choose anything. Do you see anything I'm choosing?
Do you have annotate as an option on the bar where you can like mute and unmute and do the video? Do you have something called annotate?
It might be where it says you are viewing Valerie Rapson's screen. There should be a menu that says view options.
Oh, wait a minute.
Thank you.
Here, participants, chat, share screen, record reactions. I have a Mac, maybe that's the difference.
It's on the top of your screen, as was just told. You're viewing her screen, and off to the side it says options. Click on the options and go down, and it will, one of them will be annotate, and then the annotate tools will appear on the top. I'm on a Mac too.
Thank you. Yeah, I'm on a
Thank you.
PC, so it's hard.
I don't see it.
If you're running in a web browser, sometimes the annotate option isn't available.
Okay.
So I'm sorry if you can't see it, but you'll just have to mentally play along with us. Or you can put your selections in the chat box too. I can keep an eye on that.
I'm in the chat box here, but
Well,
Right.
this one's kind of tough here. Let's see, no bar, weak bar. Yeah, I'm just gonna go with no bar here, but it's kind of a 50-50 shot. And Bridget, you can always just stick your answers in the chat box for the next one.
I don't see the chat box either.
No, man, you don't seem to have anything on yours.
Just reactions.
Try full screen view.
I'm in full screen, yeah.
Well, for those that are able to, feel free to pick this one. Do you think you see any spiral arm patterns? Yes, no, maybe. Yeah, general consensus is no for this one. All right, I'm gonna click no. All right, now it's asking me, sometimes there's a lot of questions. Is there a central bulge? And if so, how large and bright is it? Or how large is it compared with the galaxy? So basically look at the center of the picture. Do you think you see a really bright center? Do you think you see a faint center? Nothing in the middle? Basically, do you see any additional brightness in the center? Kind of moderate, it looks like people are going for, maybe large. Yeah, I think I see a little bit of brightness there in the center that might be a little bit brighter than the general galaxy, but it's kind of hard to tell. We'll go with moderate. You guys said moderate. All right, is the galaxy merging or disturbed? Does it look like it's bumping into another object? Does it look kind of teardrop shape, or do you not see anything weird with the galaxy? Yeah, so some are saying minor disturbance, some are saying none. The astronomer in me might say minor because you see the stuff on the left. Looks like there's some extra stuff at the bottom there. Maybe some material from a merging galaxy, something like that. But it looks like general consensus might have clicked none here. So I'm not going to worry about if we're right or wrong. We're just going to click none. Next. Oh my goodness, so many questions. Do you see any of these features? Ring, lens, arc, dust lane, overlapping. Do you see anything that looks like the pictures on the left? Eileen, you're a ringer for the group there. You know what you're looking at. Yeah, what do you see? Anything weird or nothing unusual? Yeah, I think I agree. So, you know, maybe overlapping, right? If you had two galaxies and maybe one in the foreground or one in the background that's faint. This dark stuff here on the left, that is actually definitely a dust lane in front of the center of the galaxy. So I'm going to go with dust lane here. And I think since there's no more next buttons, it finally lets me click done. So after that, let me clear these. We're going to get a new picture. So before I click that final button there, I just want to share a little bit more here. So we went through this process and simply answered the questions. Again, you don't have to know what a lens arc or a dust lane is. You just kind of match up the pictures and see what you're looking at. In reality, this is probably an edge-on spiral galaxy with a big dust lane across the center and a pretty bright center. So I know we can't see any spiral arms here, but the clues for me are actually the color. Spiral galaxies often have a bluish white appearance more than they do a yellow appearance. So all of the blue around the edges suggests that it's actually a spiral, and we're probably looking at it from the side with all of this dust blocking the middle. So whether or not that's really what we concluded by answering these questions is, you know, to be determined. But hopefully the general consensus, once a lot of people do this, will bring the scientists and the research to the right conclusion. So let me click done here. I think we'll get a new picture. Yeah, we will. All right. So maybe we'll do one more. I think this one will be faster based on your options. So let's go through this again. Tell me, what do you think? Smooth, features or disk, star or artifact? What do you think you're looking at here? I think this one will have a few less questions once we click the answers. Yeah, this one looks definitely a little bit more smooth. So we'll click smooth. And then shape here. What does it look like? Completely round, in between, or kind of cigar shaped? What do you think? Yeah, it's pretty round. It's actually quite circular. Completely round. Do you see anything going on? Merging, major disturbance, minor disturbance? Or does it just look like a yellow blob to you? What do you think? Yeah, general consensus seems to be none. Yeah, I don't see anything either. So we'll click that one. And then our last question here, do we see any other weird features like we saw before? There are rings, lenses, a dust lane in this one, anything overlapping? What do you think? And nothing unusual is at the bottom if you don't see anything. Yeah, a couple people are suggesting maybe a dust lane, and I agree, maybe there's a little dust lane there. Could also be an artifact on the camera. Looks like most of you have clicked nothing unusual, so we'll click that and we'll hit done. So we could sit here, you know, for hours doing these, and you get a new galaxy every time. But I like this one. I think this is kind of fun, and you get to look at pretty pictures of galaxies, and you never quite know what you're going to see, right? It might be a big, beautiful spiral-armed galaxy, or it might be a small yellow elliptical that's maybe not all that exciting to look at. But that's Galaxy Zoo. So you can spend some time later on taking a look at more galaxies, and you can always click done and talk on the bottom there. That's what brings you to the chat forum. so that you can discuss anything weird that you see. Like maybe there's two galaxies in this one. There's kind of some yellow fuzz to the right and there's some yellow in the middle. So maybe you want to chat about that. And you can also see what other people have talked about for the different pictures as well. So you can maybe join a discussion already in progress. So that's Galaxy Zoo, and we're going to keep with the theme of galaxies tonight. I'm going to bring us to one other project. We're going to quickly look at Supernova Hunters. Let me clear all of our drawings here. We'll go back a page or two. So I think Supernova Hunters is actually on the second page here. You can see there's so many cool things in different areas of astronomy. And Supernova Hunters, I think, is the one on the last page. Yeah. So what Supernova Hunters does is it basically shows you a set of 3 pictures. You have a reference image in the center. This is like an old picture of an object that we believe is a galaxy. The left is a modern day picture, or not necessarily modern day, but more recent than the picture in the center. And the image on the right is a subtraction image. So if you take, theoretically, a galaxy, and you now have a picture of a galaxy with a supernova explosion, and you subtract the two, the only thing that you should be seeing in the subtraction image is the supernova explosion, right? Galaxy plus supernova minus galaxy equals supernova. That's the mental math that you have to do for this one. So these are pictures from the Pan-STARRS set of telescopes. It's down in Hawaii. It's a 1.8 meter telescope, and that's where most of these pictures have come from. So let's get started. Let's take a look at these. So I'm just going to show you a few pages of the tutorial, because for this one you need to know a little bit about what to look for before you classify things. It's not quite as simple as the Galaxy Zoo one. So here it says a short tutorial will show you how to do the project. You will be shown 3 images. In the center is the reference image, taken a few years ago. Since then, a supernova is believed to have happened. That's the picture on the left. So here you see the galaxy. Here you see the galaxy, and that bright white dot is a supernova, a massive star that has died and exploded and gotten so bright that often it overpowers the brightness of the whole galaxy. On the right, we have our difference image. Remember, galaxy plus supernova minus galaxy equals supernova. And the green crosshairs there are theoretically centering where the supernova is, where it would have been if it happened years ago, and where it should be in the difference image. So basically it's saying that, the computer can pick these out except for when there's weird artifacts on the camera. So here, these are examples of bogus detections. So here you don't see anything. There's no galaxy here. On the left, you have this long white streak and there's a bright white center. And the computer just picked up, oh, look, there's an extra bright white dot in the difference image. That must be a supernova. But to our eyes, we see this streak, and that's kind of weird. Galaxies don't look like that. And what this actually is a row of dead pixels, or a row of broken pixels on the camera. So all of those pixels are always going to show as bright, even if there's nothing to see there. So the computer incorrectly called this a supernova, but to our eyes, we know that it looks funny. It's not actually a supernova. So those are the types of things we're going to look for. Everything you see, the computer thinks is a supernova detection, but in reality, it may or may not be. So it just tells us, how to look out for these bogus detections. Be careful of things where in the center crosshair, you just always see a white dot, even in the difference image. This is probably just the center of the galaxy being so bright that the camera can't handle it. It's getting a little saturated. And we also want to be careful of stars that are kind of, oh, that one's blinking, I'll go back here. Stars that are like really close to the edge here. These are just dark regions in between the different pieces of the camera. So anything that's really close to the edge, you should be wary about too, because often the edges of the cameras are not as trustworthy. So that's it. Let's take a look at some of these. I'm going to close the tutorial. So here's our first example. We've got our regular image in the center. Theoretically, there's a galaxy in the green crosshairs there. Here we have a bright pixel that was suggested to be a supernova, and here's the difference image. So that's the bright dot. do you think that this is actually a detection of a supernova? So here, all you gotta do is click yes or no. So what do you think? You can annotate the screen. Do you think this is a real supernova? Yeah, probably not, right? Because you don't actually see a galaxy in the regular image. And we're right on the edge of a detector here. So these detectors, these pictures might have been taken on different portions of the camera or even with different cameras. So this one is probably just a little glitch near the edge of the detector there. So I agree. We're going to click no, and we're going to click done. And this is really simple. This one's not going to ask you a million questions like Galaxy Zoo. This one is literally just, do you think you see a supernova? So let's do this one. Do you think you see a supernova? There's a galaxy. That thin gray line is indeed a galaxy. Do you think the detection on the left is actually a supernova? What do you think? Yeah, I see a bunch of votes for yes. Maybe a couple of no's. Yeah, so I actually think this one might be a supernova. If you look closely at the center image, you can see that the stars in the background are brighter. So this is a longer exposure picture, which is why you see the galaxy here. It's very faint and very far away. And you don't see the galaxy here, probably because it's just too faint. The camera didn't expose long enough. But there is a bright dot there that wasn't there before, exactly where the galaxy was. You can see it in the difference image. So that indeed might actually be a real supernova detection. So we'll click yes here. All right, let's do just a couple more. Let me erase these. What do you think about this one? Is this a real supernova detection? Potentially a theoretical galaxy here? I don't know. What do you think? Also kind of near the edge of a detector again, not as close as we were before, but oh, we got a good mixture here of yeses and nos. Now this is the beauty of Zooniverse, and I find that sometimes students get frustrated with this because they're like, I want to know the right answer, and I'm like, there is no real right answer necessarily. We don't know what the right answer is yet. That's the beauty of science. We have to collectively gather information and figure it out. So it looks like there's a few more check marks in the no box than there is the yes box. So we'll click no for this one. And then maybe we'll do one more here. Let's see. So what do you think about this one? Do we think this is a real supernova detection? Do we see any galaxy in the center image? And then the bright dot on the left. Do we think that's a supernova detection? And you can also use, again, the brightness of the stars to kind of clue you in. If you don't see anything here, and these are fainter, you expect to see anything on the left. Oops, I'm sorry, I cleared your drawings. I clicked the wrong button there. All right, do it one more time. I messed that up. Click it again. I won't click the clear button quite yet. I was trying to get my little pen away there. What do we think? Yes or no? All right, so it looks like general consensus here is the yes. So this one's tricky. I don't really know. I don't see any galaxy in the center image there. What I do see, if you can see my white arrow, there's a little dark spot, and I'm curious if that's actually like a little dead spot on the camera or something. I don't know. That one's tricky, but we think yes, so we'll click yes. So we could keep going. Again, we could spend hours and hours doing this. So it has you look through all these pictures. Sometimes you get really cool pictures of like full galaxies, and sometimes they're just little dots like this. But this one's kind of neat. You can look for exploded stars, and ultimately what we can do with this information here is we can figure out the distance to these galaxies and just figure out more information about how frequently supernova occur, how long they last. All of that information can be gathered by people just looking at these images and helping the computer, figure out whether or not these truly are supernovas. So that's just two examples of the Zooniverse project. I'll go back to the main page here. Go back to page 1. So on Zooniverse, things come and go. Right now, it looks like there's 21 astronomy projects. There's new ones that are added every month. Some go away for a little while once all the data has been analyzed. But I encourage you to look at whatever piques your interest. And literally, I promise you that in 2 minutes or less, you can jump right into these projects without any prior astronomy knowledge. You can find supernovas, study the surface of Mars, whatever you like to do. And the neat thing about these, and I should have shown this to you and I didn't, I'll go back into Galaxy Zoo for 1 second here. If you would really like to know more about the projects or more about the science, most of the projects on the right side have a field guide. And if you click this, it starts to get into, okay, why did we ask you those million questions? Why are we talking about, the features? What does it mean? What are you actually looking at? So if you want to know the science, all of that is there in a very palatable format. So Zooniverse has gotten just really great at teaching people all of the different scientific things to do and to really teach them about astronomy without having to sit through hours and hours of astronomy lectures or classes. So I'll share with you just one more project real quick. We won't actually do it, but I'll just tell you, when I'm not feeling in the mindset of astronomy, I really like to classify penguins, and there's this thing called Penguin Watch. And what we can do is we can look at cameras and we can look for penguins, and you have to identify if they're male or female, or sorry, not male or female, if they are adults or babies. So here, this one's not very populated, but you can see there's a couple of adult penguins in the background. So we could, mark the penguins for the scientists and count them and, hopefully see some really cool pictures of penguins. Oh, here's some up close ones. Look how adorable they are. So anyways, we won't spend time classifying penguins because this is an astronomy talk, but I have a lot of fun with things that are different than astronomy as well. So I encourage you to spend some time exploring the website and doing whatever interests you on here. All right, so that's really what I had for you today. Hopefully this was a fun and interactive chat session. I am happy to hang out and answer any questions about Zooniverse or just any astronomy questions in general that you have.
Are we going to have another meeting at some point?
It's a good question for Seth, I think. Oh, we can't hear you, Seth.
I'm sorry, I didn't hear the question.
Oh, I was just wondering if we were going to have another meeting in the future.
Yes, these next Friday we'll have another in our series, and I'll tell you about that in just a few minutes.
Great, thank you.
Valerie, I wanted to know who runs Zooniverse. Is it Philip Morris, or is it NASA? Who
Right, that's a great question. I don't remember. There's an about page that I'm scrolling through here. I think it's really a collection of different things. I mean, Galaxy Zoo was the original, so that was funded by whatever project. Maybe it was the people that funded the Sloan Digital Sky Survey. But now it's such a mixture of sciences that I don't think that there's one organization really running it. I'd have to look into more detail to see who's overseeing it. But scientists in any field can submit to have their projects put up for a while, and it's just one big collaborative effort.
Okay, all right, thanks. Actually, Eileen in the chat area just said it started with a bunch of astronomers at SDSS. So,
excellent, thanks.
Yep.
Where are you all? Where are you located? Are you an astronomer?
Me, yeah. So I am now a professor at SUNY Oneonta. For the last 5 years, I was at the Dudley Observatory, which was in Schenectady and is now over at Siena College in Albany. So that's what I do. I have a PhD in astrophysics, and my specialty was looking at disks around young stars. So trying to understand how planets and stars form.
When I got out of high school, when I graduated from high school, my father said to me, we discussed my education, and he said to me, well, what would you like to be? Well, yeah. I'm an immigrant from Europe, so we were very poor. And I said, I want to be an astronomer.
Ooh.
I love the stars. I don't know, I've always been in love with the stars. And he said to me, you be a secretary, you have a job for life. That was our discussion of our education.
Oh no.
This is wonderful to fall on my lap. I'd love to get involved in it.
Yeah. So it's never too late to get into it. And the Zooniverse stuff is great because you're literally helping contribute to science. And, you know, with any astronomy knowledge that you have, I'm sure you'll do a great job at all of these projects. So it's a lot of fun.
So I did just post some of the Adirondack Sky Center and Observatory information, contact information, email, phone number, website, Facebook, and our YouTube channel. And I also mentioned that this talk, as well as the other ones, Bridget, especially if you're interested, if you click on that link to our YouTube channel, you'll be able to see all of the ones that we've done so far. These get posted the Saturday after the Friday night of the particular lecture. And
The Adirondacks.
oh, okay. Well, you're right near us. And on that note, next Friday, October 2nd at 7 o'clock, Blue Sunsets and Other Scattered Lights by Josh Thomas. And there's a registration link right in the chat area now. You guys get early registration from being attendees here tonight.
Oh, wow. Where do I see that?
You'll have to find the chat box first.
Got it.
Anyway, what other questions? Any other questions from folks? Well, this was by far the most interactive
Yay.
that we've
was
had
the
so
goal.
far. Yeah,
Nobody gets to sleep through my lectures ever. I'm always poking for questions.
you've definitely piqued my interest in the Zooniverse. I had been in there maybe once or twice just for fun, but definitely want to be more thorough, especially in some of these astronomy areas, and maybe penguins and raccoons also.
Fantastic. Well, thank you so much for having me. This is great. I'm so glad to see everybody, and it's wonderful to be here.
Well, thank you very much. And I see applause coming from members of the audience. So thank you again.
I don't see the sign up for next week's on the chat box.
I will, let me send it out again.
There you go.
Registration link. Is that where we do it?
Yep, the registration link, yes.
I just click on that. Whoop.
Yep, to register, yep.
Oh, okay. All right. Thank you.
Does everybody see it? All right, well, again, thank you so much for doing this for us. Your presentations are always so interesting and especially interactive tonight. So
You're very welcome.
That helps late on a Friday night. And for everyone else, thank you so much for coming again on a Friday night. We'll hopefully see you back here next Friday with Josh and his talk. Make sure you register in advance for that. And if you get an opportunity, boogie on over to our website and click on that donation link. Help us get that $15 million for this wonderful Astro Science Center behind me, complete with planetarium, lecture wall, interactive classroom, and everything about it is hands-on. You won't be able to get through there without being moved by something in space. So thanks again, and we'll see you next Friday. Good night, everybody.
Good night.